Hello and welcome to the Earth Observed podcast, a podcast where I sit down with founders, technical leaders, and the minds shaping the future of Earth data, geospatial technology, and atmospheric AI across Europe, North America, and beyond, of course. In each episode, we take a vertical dive into a topic chosen by our guests, giving you a front row seat to the ideas, the tools, and the challenges that enable innovation from space to subsurface and everything in between. Today, I have the pleasure of being joined by Bernhard, co-founder of Earthscale.ai, and Bernhard has spent his career turning vast streams of Earth observation data into practical insights. At Black Shark, he worked on global scale machine learning. At Pashama, he helped bring transparency to the carbon markets. And along the way, he realized that the same tools powering these projects could benefit a much wider audience. That insight led him to co-found Earthscale, where he's building geospatial tooling that let others focus on solving their own business challenges. And today, Bernhard would like to talk about how is AI making our geospatial tools obsolete? So Bernhard, thank you very much for joining us today. It's much appreciated. How are you?
Pretty good. Thank you for having me.
Yeah, no, absolute pleasure. We've spoken for some time now, probably over the past year, and I've seen sort of this journey from afar of you founding Earthscale and where you are today. It's fantastic to see, and I'm most definitely cheering for you. Sorry, from the sides. That is also another reason as to why I wanted to get you onto this episode today. I feel like many more people should know about Earthscale, about yourself, and the work that you're doing in general. So, I guess today we're going to talk about how AI may be making our geospatial tooling obsolete. I guess, did you just want to shed some light on what that may mean to the viewer without, going into too much detail?
Certainly. I think AI is changing almost any product, any work stream out there. And I think a similar thing is happening in the geospatial world. I believe that at the moment there might still be a small difference in that certain parts of geospatial workflows will be a really good fit for AI, for large language models, whereas others, in particular infrastructure and just dealing with the vast amounts of data that you get through Earth observation, are just generally different at the moment from what we're seeing. So I think as far as we're seeing it, there is no like one big model that will rule them all, similar to ChatGPT maybe.
Yeah, that's an interesting one. I was actually having a conversation with an engineering manager actually this morning, who made me stop and think, because we were talking about this shift in focus within the geospatial arena, how a lot more businesses are now looking at large language models, generative AI, and I spoke about how is the geospatial domain experience a necessity in the talent market nowadays, given the focus on this particular area? And is it actually a case that people just want good engineers, good scientists, regardless of the background that they're coming from? So it's a really interesting point you made there. I think this particular person's response was, if I hired 10 people tomorrow, 8 would be software engineers and 2 would have a geospatial background. As geospatial leans into generative AI and LLMs, that 8-2 split makes sense, in my opinion, in that foundational models and vision language stacks have lowered the barrier to entry on domain depth. And the hard part, in my opinion, is everything actually around that model in particular. You win by plumbing data and serving reliably, whether that be through stack discipline or cloud optimized geotiffs, GeoParquet, tiling and spatiotemporal indexing as well. And ultimately, production is a distributed systems problem. Even when you skip fine tuning and lean on the RAG, you still need spatially aware chunking, metadata embeddings, temporal windows. So ultimately, hiring does shift. Bring in generally strong engineers who ultimately own end-to-end paths from ingesting to tile APIs to retrieval to monitoring, and then layer a small core of geospatial specialists, being the 2-to-8 ratio, to ultimately set those standards, catch assumptions, and teach the 20% of domain knowledge that prevents 80% of mistakes. I don't know if you're with me there in what I mean by that, but I do feel like it is starting to shape the way in which teams like Earthscale are potentially going to be hiring in the future. What are your thoughts on that, out of interest?
I think I would agree on the 80-20 split, especially for people building products on top of Earth observation, right? Because usually there's a need for Pajama. There was a need to verify carbon projects. For Blackshark, there was a need to detect buildings on the global scale. And those geospatial engineers, similar to all the other software engineers, are a means to an end, right? That's the way I see it. And those kind of 20% focusing on the special cases around geospatial are just something that you need. I would think for us as Earthscale internally, we definitely have a higher percentage on folks specializing on geospatial, and actually very kind of deep geospatial, the kind of in depth of GDAL and whatnot. Because what we want to do is maybe we can even lower those 20% for people that were building products, right? And provide services that you bring us any data, we can tile it on a map. We can feed it into your models. We provide kind of that part, so you don't have to hire those specialists, because as you know, best of all people, there are only so many out there, and we can enable more people to build products with geospatial data, right? Like just lowering the entry barrier by taking away that need for those 20%. And we are seeing, if you provide the right infrastructure, regular quote unquote software engineers will get you really far. And in particular, in combination with LLMs, they can build amazing products in almost no time. So that's kind of the hope that we're having.
I've had cases recently where I've met with businesses working in the carbon markets, for example, looking for those in applied AI, for example, and they are looking for scientists who have experience with like Bayesian statistics or Gaussian processes, causal inference. And when you get to the nice to have or bonus part of the job description, that's where the geospatial element comes in, because I feel like that part is a lot easier to understand, to learn, than maybe some of the methodologies within the machine learning stack that is required in this job description. So it's definitely not to discount those geospatial specialists, and of course, if anything, is to encourage them to keep on developing themselves, upskilling themselves, but also to really embed and embrace this shift in utilizing AI within geospatial, because in my opinion, that is going to be where we are going to be heading in the next 6 to 12 to 18 months. And I guess that leads me perfectly onto Earthscale AI. I'm keen to understand a bit more about the business. I guess the best place to start would be just a brief introduction to Earthscale AI and what it is that you guys do over there.
If you break it down into one sentence, we want to provide infrastructure that can serve your geospatial assets, make it as easy as possible to enable you to use your geospatial assets, whether you have them on your own buckets, whether you want to use open data. So we want to enable you to build a product on top of data you need or have. This came out of all of us. I've co-founded this with Noah and Felix, and all of us seeing that the same or a very similar technology stack exists over and over again across different companies. There are slight variations usually according to the use case, but generally it's the same stack. And so we decided, okay, can't we take out certain pieces? We don't want to provide a full geospatial platform that is all integrated and everything, because we don't think it's a good approach. But we take out certain pieces that you can then use within your tooling, just kind of as an add-on to what you already have. You don't need to move data around because that, we don't like the proprietary lock-in. We try to be something that sits next to your data and
Hmm.
just gives it superpowers, really. So that's what we're trying to do. And in particular, that would be, for example, visualizing your data. That would be running certain spatial analysis on top, and all the things that need very detailed geospatial knowledge about projections and about edge cases, around pixels, around certain things that you just need to know. We take those things away from you, but you keep all your data. You
Nice.
keep all your infrastructure, etc.
Yeah, amazing. And speaking of AI, I'm keen to understand how do you see advances in AI changing the geospatial landscape?
Mhm. I think there are probably two parts of this. I think that there's one big part around large language models, right?
Yeah.
That's all over the news, where I think those models are just becoming more and more powerful. And in particular, when you talk about agents, right? Like, these models now know how to use tools.
Hmm.
And on that end, we as Earthscale want to provide a model with tools, right? Like, if a model figures out, okay, I need to know how much biomass there is in Austria, um, we can be a resource, right, that the model goes to and asks that question, and we come back with a sound answer that is not hallucinated, right? And that requires some compute potentially, but that's a part that I think we can do that the AI cannot do.
Yeah.
So
Yeah.
that is one end on the kind of large AI space, and the second one being more geospatial foundation models, which a lot of people are working on. And I think those will improve those tools. They will provide better search through embeddings potentially. I think that's something
Yeah.
that's becoming quite big at the moment. They will do better classification, etc. So I think they will enable people to build better geospatial products, like actual data products. I believe.
Yeah, absolutely. Yeah, I've actually been looking into some foundational models myself recently, um, trying to sort of wrap my head around them. I think those that come to mind are Clay, developed by the guys over at Legend AI, and also Prithvi. I believe, from my understanding, the one developed by IBM and NASA in collaboration. Yeah, some really interesting stuff. Those types of keywords, should I say, are starting to pop up more frequently in those positions that I'm hiring for, more frequently in applied science, as I've mentioned already, machine learning, AI engineering. So yeah, no, absolutely. And speaking about some of the tooling and the platforms, what platforms do you most often see people in this particular industry using?
Mhm. Yeah. So when answering this, we see customers coming with platforms that they don't particularly like. We see people coming in that are thinking about building their own. So my view, is somewhat limited to kind of people that I've talked to. That being said, we've talked to quite a lot of folks over time.
Mhm.
I think you see a lot of the big players, Earth Engine, Planetary Computer,
Yeah.
Esri, definitely. Just people are in that ecosystem, right? And they continue to use the ecosystem. And then usually when they get to the edges of what those systems are capable of, or they have like large enough use cases that they are not financially feasible, we usually see people, cook their own. And that's basically what we want to simplify. We've used, or I've personally used most of those platforms, um, and seen some of the rough edges here and there, and that's things that we want to do hopefully better. We don't want to have one platform to lock everybody in, but rather just have a set of tools that you can use alongside your data, like an add-on situation.
Yeah, for sure. And do you recognize any particular gaps within the technology landscape across geospatial, across Earth data, atmospheric AI, anything of that realm really?
Mhm. I think all the tools are there, really. Like, all people have built amazing things. I don't think the one platform to rule them all exists just yet. I think, Earth Engine is a great example of a tool that's very, very capable. Um, but I think one of the gaps is just the entry barrier and maybe the usability of getting into those tools, right? Like doing so, Earth Engine is an amazing tool. It is incredibly powerful. But just getting into using Earth Engine is a step, right? You need to have some JavaScript knowledge. You need to sign up. You need to have a GCP account, right? I think there's a lot of steps, right? And I think, yeah, that the biggest entry barrier, or the biggest gap for me would be the product. Not so much the technology. I believe the technology exists, and it exists in many places and across many companies. But the actual product of making it really, really easy, right? Like someone with very little understanding of geospatial, and in my dream world, right? And this is not something that Earthscale can do right now, but it's kind of a North Star that we're working towards. Can come in, they have an idea, they have maybe some data, and just visualizing it, right? Like they have data on a bucket, or wherever they want to store it, right? And they come in, bring their data, and it shows up on a map. And that is incredibly difficult to do in some of those tools, which I think is a base capability, right? Like that you should support. So short answer, I think the product is not there yet. Yeah.
And let's talk about this North Star then. You know, I don't want to reveal too much because I feel like let's keep people waiting in anticipation. I think that's you know the right thing to do here. But you know, there has to be a greater inspiration here. This kind of, you know, can't sleep at night idea. Why is it that you want to build this type of product? Why is it that you want to get to that North Star? Why is that North Star your North Star?
I think it's having been a customer of all those tools myself over the years. You know, and I've tried most of them. I've very deeply, you know, integrated with some, and there was always something missing, right? There was always something that really, I was like, you know, I don't want to copy over my data to that bucket because at certain size, right, like it just becomes unfeasible. Or I don't want to have like a second hierarchy and structure of my data because that I need to maintain. And I think there were just certain pieces that I missed, of like, this could be so great, you know, if it had these little other details. And with someone else's product, you can't change it. But you know, we now luckily have the chance to build something that we always wanted to have as engineers. So this is a tool that I would have liked, and if it would have existed, like that I would have bought for Black Shark, for Pajama, because we've built things that already existed in other places but weren't just right. So I think we're trying to solve for that gap, so that other people, I usually joke, like we build tile servers so that other people don't have to, because it's not fun work. So yeah, just making data accessible, because I believe having Earth observation data accessible to more people will lead to greater products and will just lead to benefits to the whole economy, really.
Mm-hmm. And I feel like where Earthscale is at this moment in time, it's still in its infancy. I think that's fair to say. I'm keen to understand, based off of your time at places like Black Shark and Pashama, you've had some fantastic times there, some brilliant memories, some great experiences. But I feel like being on a podcast, you know, being in these discussions, it's all about vulnerability. It's exactly what I'm doing right now by even doing this podcast. I've never done one in my life, but I'm just keen to understand, are there any early technical choices in your career that you've maybe made mistakes that shape the way you do things now at Earthscale?
Yes, many. You know, I think being one thing I'm looking forward to in my engineering career, and luckily I do get to do a lot of engineering still, is the ability to look back 5 years, 10 years, you know, look at old code, old code, old decisions that, you know, I've made in the past, and just look back and was like, oh, this is really stupid. And this is small details, like caring about the wrong things. But
Mm-hmm.
one major decision, I think, that one takeaway, Black Shark, right? There's always this capability of doing a whole world run, like running over 50 centimeter imagery, because Black Shark originated based off a flight simulator. Did all the building detection for Microsoft Flight Simulator, which meant running a machine learning model over 50 centimeter imagery, which is tons and tons of imagery. And that then became a product. And kind of there was this, we can run over the whole world. And running over the whole world is amazing from an engineering perspective. but it also takes a lot of time to build and shapes a lot of decisions. So I think looking back, maybe it would have been smarter to just start off at country scale, continental scale, and see who is a good potential buyer for those products, instead of just focusing on like a whole world run. Because it turns out satellite imagery is incredibly expensive, and most people don't actually need the insights from the whole world. So I think they're those decisions where you're like, okay, looking back, at the time it made perfect sense, right? At the time it seemed like the right thing to do. Looking back now, that was probably one thing to push back on.
So, quite simply speaking, rather than looking at a problem on a macro scale, trying to answer more micro problems at a greater scale, ultimately, I think that's what I've got from that. Yeah,
and
I
and
like
really
that.
focusing on what does the user, someone has at the end of the day, someone has to put down money to run your stuff, right? Like the kind of the economics of that have to work out, and making sure that someone actually is willing to pay for that, right? Similarly, this at Earthscale now, we could have built we could have sat down, shut our doors for 3 years. We luckily have some funding. Started building something that we had in our minds, never validated, come out after 3 years and then fail. But rather than that, we thought really hard about like what's the small incremental piece. We have a plan in mind of what the infrastructure should look like at the end, but we started out, okay, well, what's the smallest piece that we can build that provides value to someone, where someone is willing to put in some dollars so that they can do something that they can't do right now. And for us, visualization was the first obvious part, because a lot of geospatial data, frankly, is sitting around on buckets. People use it, people build models off of it, but no one can ever look at it. That's a reality that I've seen across many companies. Yeah.
And I would imagine that from a visualization perspective, it's great being able to see it, but then it's a case of understanding it as well, and making it intuitive. Especially for those non-technical stakeholders. Are you finding any challenges in making that data visible, but then also digestible as well?
I think there are multiple parts to this. So one of them is the tool definitely needs to be very easy, or that's our goal at least. It needs to be very easy to use for anyone in the company, right? Like if your head of science comes along and is like, what geospatial data do we have? You point them to the thing, they can scroll around, right? And a big part of that should be, okay, any visualization settings should come with a reasonable default, right? Like you drop things in and they look good, right? And they have the right color scheme, they have the right min max values, like a lot of things just that you don't actually think about, like they should just work, right? Like again, the product part where you just shouldn't need to configure things. They should just work.
Yeah. So tell me then, forward thinking, forward guidance. I once again don't want you to reveal a great deal. I'm sure you're probably not allowed to either. What's in the works over the next 6 to 12 months with Earthscale? You've already mentioned that there's a North Star that you're going to continuously work to achieve, but is there any exciting updates? Anything that you are able to tell the audience to maybe sprinkle some excitement?
Definitely things that I'm not able to tell, but like on a just very general sense, we have the ability to basically read from almost any data source. Almost anything reasonable, right? Like we try to be really good there on just supporting most of what we can. And at the moment, you can visualize all of it. You can get certain data pieces out. You can get like some statistics and whatnot. But I think we want to work on more output formats, right? Like we personally, one of the use cases we've always had is sensor fusion, just making sure, or it's not really sensor fusion, it's more like automatic regridding into the same pixel grid so that you can do machine learning on top of data. And then also one big part of getting your data out would be the ability to feed it into a large language model. Because again, we think there's still a use case for the data scientist or for the regular product person, right, building a product. But potentially something that we're seeing and we're currently exploring options there is just giving a large language model tools, right? Like we have a customer brings a large collection of data sets. They're looking for something. We can recommend which are the best data sets. we can then show certain areas of that data set. We can run spatial analysis over those, right? But we just do the very basic operations, but the large language model then decides on what they want to do. And at the moment, our vision is not to build our own kind of map or, the classical geospatial AI that you see all over LinkedIn, where you have a map and then you can type in text and whatnot. We want to just deeply integrate with good models that exist right now, because we think that's where things are headed.
Yeah, that's really, really interesting, and no, I'm incredibly excited to see the developments of that. Well, look, Bernhard, thank you so much for joining myself and us watching Earth Observed today. I would love to get you on again over the next 6 to 12 months to share, where you were today and where you are tomorrow. So yes, a real pleasure, and thank you so much for joining. It's been an absolute pleasure.
Thank you again for having me.
Hello, and thank you for watching today's episode of Earth Observed, powered by DeepRec.ai. If you're interested in joining me for an episode of your own to discuss a topic of your choice, do get in contact with me. And of course, if you are looking to scale your team within geospatial, Earth data, or atmospheric AI, please do get in contact. I'd love to understand how I can support you. Until next time, have a great day.